expressions again. What's an expression?
A number, it's like
It
without
has an
having
equal sign. It doesn't have.
It doesn't have an equal sign, right? So an expression, how would we say it? It's a problem without an equal sign. Okay? So this is where we again talk about, obviously that, but, so some kind of problem without an equal sign. That has terms in it. What did we call a term the other day? What three things were a term?
coefficient, variable,
A number.
Okay. A number. A variable. Or what was the last thing?
a sign,
What if I put both of these together? Yeah, if I put a number and a variable together, we could call it a what?
Product.
A product, right? So, examples of each. Again, as we had the other day, obviously a number doesn't matter if it's positive or negative. A variable could be a variable by itself, or it could have an exponent, right? But it's still a variable. And then a product is putting a number and a variable together. Okay? Because we actually multiplied those together. And then we could have negatives, we could have positives. So when we talk about expressions in terms, the terms are separated by what? Now say what you said, Kenzie. Operations, right? And so when we talk about expressions again, then we're going to have something that has something in between it, like a plus or a minus. So we have x plus 14, for instance. And we can put parentheses around that so we can group it together. And what did we call it together when we group something together with parentheses? Q word. Quantity, right? Quantity. Okay? Then we could have it where it was more than just 2. So we could have x squared plus 4x minus 8. Now there's 3 terms in that same problem. But again, they're still expressions because they don't have an equal sign. Now remember what we said the other day also, is that yes, these are operators like Kenzie said, but they also act as what? The sign of the term that they're in front of. So 4x is positive, 8 is actually negative. And what do I call negative 8 at the end? By itself. A number by itself at the end. C word. Constant, right? Coefficient was the 4 here. A constant is the number at the end. And we should always try to write the constant at the end. Okay? So the most important thing is recognizing if we have terms. So up here, x, 7. Look at this big long one right here. 9, A, B, C, D, E, F, G, H, A, whatever it goes to, right? How many terms is that? Just one, right? Because they're all doing what to each other?
They're just together.
So if they're just together, what would we say they're doing to each other? They're being multiplied together, right? That's a way of showing multiplication. Then we start looking at terms in general, right? So x is just one term. X plus 7, how many terms do I have? 2, right? Because remember, a term can be a variable or a number. So if it's separated, if there's a plus or a minus in there, then we start counting it as a second term. Everybody agree? And then the next one, x plus, so up here we had x squared plus 4x minus 8. This would be 3 terms. And another example of 3 terms would be x plus 7 minus 8mn, right? There's 3 distinct terms there. Everybody okay with that? All right. Remember then, we can always talk about our coefficient again and the constant at the end. And then, don't forget that this minus sign, we could rewrite the problem, and x squared plus 4x, we could write this as plus a negative 8. This this 3 terms and this 3 terms are the exact same thing. Just notice that it's written different at the end, but they mean the exact same thing. Okay? Personally, I would try to get rid of thinking about this one right here, because if you have multiple signs in one term, it might start to confuse you. So this is a lot easier to read and look at than this is over here, to me. And again, you should be able to just start getting used to it a little bit more. Okay? Questions there? That's all the stuff kind of we talked about the other day. So now we talk about like terms. And this is a really, really important concept to think about. What would you consider like terms, or why do we say like terms compared to just terms?
Like terms are similar.
Okay, and how are they similar?
Maybe they have the same number or variable.
Okay, so which one do you think it is?
No, variable.
Same variable, okay? So this has to be the exact same thing. When we say this now, we are talking specifically about the variable, okay? So the variable, including the exponent. So this is what we're going to talk about today. Talking about like terms, but it has to include the variable and its exponent. And as I told you the other day, when I learned this way back when, my algebra teacher talked about farm animals, basically, okay? So what we're saying is, we're trying to figure out what the exact same farm animal is. So is 2x plus 8y, I think we can distinctly tell that those are totally different, right? And x and a y have to be totally different because they're different letters. So I said way back in the day that this was a cow plus a horse. And if you have cows and horses, you're never going to add them together. It's just weird, right? Okay, so then we get into, if I have more, what am I actually looking at? So now, if I have cows and horses at the beginning, and now I have another set of x's, can I consider them more cows?
Yeah.
Are they exactly the same thing with respect to the variable and the exponent, right? And then we have, throw in some zebras, right? So this and this and this are all different kinds of animals. They're not exactly the same. So we're picking the things that are exactly the same, and we're going to concentrate on them. So when you write down this problem, or think about this problem on the quiz or the test, if you want to rewrite the problem where you're grouping all of your like terms together, you can totally do that. You just got to make sure that you take the sign along with it. All right? So, in this particular case, we circled the two groups of x's. Now, how do I bring them together? You just add them, right? So, when we're going to do this now, when they ask us to talk about this, they're going to ask us to combine like terms. So that means we are going to add or subtract. Now obviously you can go through and you can multiply these two, but that's a little down the line, I guess, for us. So we're going to add or subtract the what? What part of the problem do I add and subtract?
The numbers.
The numbers, or what would we call those numbers?
Coefficients.
The coefficients. So here's a question for everyone. If I'm going to add my coefficients, obviously I just take 2 plus 3, which is 5. Does my x change?
Yeah, well, you don't have to have x squared, because you have 2 x's.
Okay, so that's a question. How many people think it stays exactly the same?
What do you mean by 6?
Meaning x.
It'd just be 5x.
It'd just be 5x. So the question is, does it turn into 5x or does it turn into 5x squared?
5x squared.
What do you think, Michael? You think it's squared too?
Because if you just have 5x, that's 1x. You need to have.
Okay, so if I tell it to you this way, if I have 5 or 2 cows, and I bring in 3 more cows, did those cows or kind of cows change? But if I wrote this as 5x squared, is 5x squared in the original problem anymore?
No.
So how do you add something? So if I have apples and I add more apples, how do I get a different kind of apple?
You change the variable. Like you.
Now you're going to totally throw out the x?
No, like you keep the x, but like you can't get something different. Like.
Okay. So what I'm getting at here is we're adding and subtracting the coefficients. Big star. The variable and exponent, what would you say?
So
Stay the same.
So it'd just be 5x.
yeah.
So it's just 5x.
Well, how do you express that you have multiple x's then? Because
What do you mean if I have multiple x's?
It's not just 1x, you have 2 different.
But it's one big.
I know, but it's basically 2 plus 3.
Yeah.
But it's 2 apples plus 3 more apples. The apples never changed. Okay? So we just got another pile that's bigger. And we added to it.
Another way to explain it is like x equals 2, and then figure out 2 times 2 is 4, 3 times 2 is 6, and then add 0 is 10. Sorry, I don't know if that makes sense.
Kind of. Yeah. Okay, so in our problem right here, this is what we're going to concentrate on. Now here's the question. So if this turns into, what'd you say? How many x's?
2x. So it'd be.
Add or subtract the coefficients. 5, and the variable stays the same. What about these other 2 things?
It just be plus 8y plus 3z.
That's right. So they just come along for the ride in a sense. Okay? So here's another one then. How about this? What if I have the exact same problem, but I change the second one to x squared? Is this x and this x the same thing, even though the variable is the same, but the exponents aren't? So are they the same? Can I add the numbers together?
No.
Everybody in agreement?
Yeah.
Well, you can add the numbers together, but not the x's.
No.
But the numbers go with the
It's
x's,
2 different things.
Yeah.
right?
They're 2 different apples.
So they're 2 different apples, right? So this is a red apple and this is a green apple.
Yeah.
So they're still apples, so they kind of look alike, but they're not exactly the same apple.
So is that just your answer then?
So this
The problem,
would be my answer.
The problem is your answer.
Yes.
Yeah.
That makes sense? The apples are right. Or we got a brown cow and a black cow. Right?
So if you can't add or do anything together, then it's just that.
Then it's just that.
The problem.
Exactly right. The problem is the answer. Okay? So that's what we're going to do today. And we're going to really concentrate on some of those things. So, first example. We're looking at this one right here. Okay?
Can you put a 1 in front of that x?
Say it one more
Can
time.
you put a 1 in front of that x?
Exactly right. We can always put a 1 in front
So
of
then
that
would your
x.
answer be 5x? Or would it
Uh,
just be 4?
In this particular case, so if we do this one, 4x, read it out,
Minus 3.
minus x
Plus
It's
2y.
2 or plus 2y.
plus 2y. Okay, so Landon's first question was, can I put a 1 here? I can always put a 1 there. I can always put a 1 there. Most of the time, we just don't. Okay? So the question then comes, if I was going to simplify this, again, what's simplify mean?
Break it down to the smallest.
Make it as small as I possibly can. Do I have like terms?
Yeah.
Do I have apples that are the exact same apple?
Yes.
Okay, so then we go back to either add or subtract the coefficients. So what's 4x minus 1x? 3x, right? So we get 3x, and then let's write it in alphabetical order,
Plus 2y minus 3.
and then minus 3. Everybody okay with that?
Yeah.
Okay, so if they ask us now, how many different terms do I have in this problem?
2.
3.
Oh,
Right?
I have to go there.
An x and a y, and what is this called again? A constant. Okay, but that's still a term. Okay? Like terms, we already did that and simplified them. Okay? Coefficients. What's the coefficient on the x?
3.
3?
2.
2?
3.
Does this have a coefficient?
No.
No, because it's a
Constant.
constant. Okay? And then the constants. All right? Make sense? All right, up here. Next one. 2m minus n plus 6m minus 3p plus 2n. So when you do this on your homework, they're going to ask you to identify the number of terms. They want you to do this before you simplify. So how many terms do I have in that problem right there before I simplify? 1, 2, 3, 4, 5.
Is that counting the n?
Yeah, 'cause
Yes.
You could just put one n and that becomes a term.
Right. So this is a term right here. The m, this n, this m, this p, and this n. Agreed? Okay, so what are like terms? Do I have groups of m's?
Yes.
Yes. Do I have groups of n's?
Yep.
Yes. And then I would have just one group of p's.
So
So,
how many would it be?
there would be 3 different terms. Right?
Question.
Okay, so looking at the n's, it's 6m minus plus 2n. What would that?
2m plus 6m, right?
So you just like flip it?
No, it'd be 8m.
Well, here's my 2.
Oh, I was looking at 2n.
Oh, yeah. Oh, you're looking at the ends?
Yeah, no, I'm looking at the m's. But,
Okay. So there's a 2m plus 6m.
Okay, no, I get it.
So I get 8m. What do I get for my ends?
1.
1 n, positive n, right?
Yeah,
Minus
And then minus 3p.
I thought the 2n on the way n was an n from here.
Oh,
What?
Yeah, change before. It's because you're 2 rows closer.
Okay, so,
I like you.
okay with this? Now we're talking about, so the first thing you have to do is this process. Just talking about terms. Now we're going to try to combine like terms. When you combine like terms, this is for the rest of your mathematical life. If you guys end up taking even pre-calc or calculus, you would still do this process every single time. All right? Number 1, the first thing that I'm going to do is eliminate, what's that mean?
Get rid of it.
Get rid of. Eliminate parentheses. What did we do yesterday to eliminate parentheses?
You just did times and then.
What did we call that?
Distributed property.
Distributed. So, to eliminate parentheses, we're going to distribute. What does it mean to distribute again? As Mr. Teal just said, we're going to multiply. So, from here on out, if there's parentheses in the problem, the first thing you have to do is get rid of those parentheses. Okay? Second thing, we're going to combine like terms. Now, when we get into equations, this is going to get a little bit more complicated because there's going to be more things to do. But for us right now, we're just going to concentrate on these 2 steps. So we're going to get rid of all the parentheses, and then we're going to combine like terms by what we just talked about right over here in this process. Okay? Everybody okay with that? What do you look confused?
You say eliminate the parentheses, what do you mean?
Like multiply what's in the parentheses?
No, that term on the outside. no.
that.
Yeah, what we did in our homework the other day, or just yesterday, okay? That we handed in. All right, so we start out real simple. 5x plus 4x. What do we get?
9x.
9x. Everybody good? Simple enough, right? So if we go on one step further and say 2x minus 3x squared, what's my answer?
That's easy.
The problem is my answer, right? Everybody good with those? That's about as simple as we can get, right? So then we get a little bit more complicated by throwing something else in there. 8n plus 4 plus 4n. So again now, if you wanted to, you could always rewrite the problem. So if this was in the book and you wanted to write down the problem, remember, I can rearrange the problem because it's all addition, right? And so if you wanted to bring these together and put parentheses around them, because they're both ends, you can do that. Now obviously you don't have to, but if this confuses you, that's what I would do, okay? So, whether you have to do that or not, I'm looking at like terms, right? So I'm looking at my groups of n's. How many n's do I have?
12n.
12n or n squared?
12n.
Just n, it doesn't change, right? And then what?
Plus four.
Plus 4.
Plus 4. Oops, I forgot the end. And I'm done, right?
Yep.
Cow and a horse, can't add them together. A nut and a person, can't add them together. We got a lot of nuts in here, but you can't add them together. Okay? You guys are Alright, try it out. Right here. At least think about it.
I already did it. Oh, I already got it. Why do
Let's do the adults, Jim. Let's do all of them.
What is your
Sure.
What is your around?
Hey, concentrate.
Do all of them. That's
Alright, so work on these ones. And then we'll come back and talk about all of them.
For that second one up there,
Uh-huh.
would you take the 3, multiply it like that? Like, would you
Yes.
do that?
Yes. Alright, these ones over here, we'll get to those in a second. We'll talk about them in just a second because those are kind of the newest ones. The first one, down at the bottom,
What I supposed
should be easy, right?
to? Yeah.
This is just doing what we had kind of built off of. So, what would you say?
What's 4 minus 7?
X, what?
1x
plus
4
minus 7.
Well, aren't plus 4 and minus 7 both numbers?
Yeah.
So do it. What's 4 minus 7?
Oh,
negative
3.
Negative 3. So my answer should have been x minus 3.
X minus 2?
Yeah.
Yeah, because it's just negative.
Oh,
you
right?
take the sign.
So again, if you wanted to write this as x plus negative 3, those are the same thing. Again. Again.
Okay, we're good.
Okay? Everybody good with that one?
Yeah.
Alright. This one up here. First thing that I have to do again, oh, I erased it.
Distribute.
Distribute, right? So what do I get when I distribute?
4n minus 8n.
Perfect. Everybody agree?
Yeah, that's yours.
Can I do anything else to that?
Nope.
No. But if the directions say to simplify, you have to do that step.
What do you mean that step?
Distribute.
Oh.
You cannot leave this as your answer.
Wouldn't you just do that anyways, or no? You don't-
Yeah, but that's what it's talking about by saying simplify.
Okay,
You can't just circle this one and say that's my answer. Okay? Because you have to distribute and get rid of the parentheses. So the next one now, we're still building, right? We're getting harder and harder. So what am I going to distribute? Remember, I always have to distribute first because going back to the order of operations, what's my first letter? P, right? Parentheses, which means I still want to multiply. So I'm going to distribute, and I'm going to multiply there, and then there, right? So in the original problem, the x just comes straight down. What do I get when I distribute?
3x plus 4y.
3x plus
4y.
Plus
12y.
12y. And now what?
It's just 4x plus 12y.
So this is a 1. Remember, I can always write that 1, I just don't write it all the time. 1 plus 3 is
4x.
plus 12y. Can I add my 4 and my 12?
No.
Cow and a horse, right?
No.
Definitely don't want to add them together. So the next one, basically exactly like what we just got done doing, but here's the question. I want everybody to think, don't say anything out loud. What, if you already did this one, did you distribute here?
Did you?
What did you distribute in this problem?
Negative 2y.
You're supposed to be thinking.
Oh.
What number did you distribute?
Let me say, negative 1 or negative 2.
-2. Don't forget that this operation is also the sign of that 2. So I am distributing that whole number right there. So when I distribute, what do I get?
2x.
Negative 2y. Oh yeah, sorry. 2x just comes straight down.
And then
Negative
negative
2y.
2y. And then minus 5x.
10x.
Oh, 10x, yeah.
Remember, I have to multiply every single time. Now, what do I get for my x's?
Negative 8x.
Negative 8x.
2x minus 10x, right? And again, if you have to take the time to write that out, write it out. We're not going to make fun of you for showing work. And then we're back to keep, change, right? But again, if you're starting to get used to it, you don't even have to do keep, change. So you got what? Negative 8x, you said?
Yeah, minus.
Minus 2y.
And that's your answer.
And this would be the answer. Okay? Let's try one more. 3x plus 7 parentheses 5 minus x. Try it out. So again, every single time I gotta get rid of my parentheses first.
Oh, this is really
So the first thing I have to do is distribute again, right? And I'm distributing 7 through my parentheses. So 3x comes straight down. And what did I get when I distributed?
Plus 35 minus 7x.
7x.
Awesome.
And then you get
Negative
negative
4x
4x
plus 35.
Awesome. Here's one more quick one. Let's just say that we would have done the problem and we would have had 3x plus 35 minus 3x. What happens if I had the exact same thing but they have different signs?
It's just 0.
So
So it's just 35.
So basically I can just cross those out and I just get the number that's left over. Okay? Questions? The most important concept for a long while is this one right here. And it can only add or subtract like terms. You might have to take a picture because you're going to probably run out of time.